Hello, everyone. Welcome to this edition of Tech Spark. I'm your host today. My name is Kai Lee. I'm the product manager at Meanwhile USA. Joining me today is Brian Liu. He is our engineering manager at Meanwhile USA. So our topic today will be focused on the inverter products. So we're going to be discussing how Meanwhile inverters are shaping the future of a sustainable future. So so let us get started. So Brian, can you tell us about what is an inverter, right? We let the audience know what inverters are.
So, just simple inverter is an opposite of the power supply that you guys have been selling. So it's take DC input and output AC, like what you see on the wall. And it's usually powered by a battery bank or a battery charger you along with it. And lighting motor can plug directly into the inverter to get power instead of plug into the wall. So you can think of it like another device that can power the motor or your light separately.
Mm-hmm. So this is different from the products that meanwhile we sell a lot of, the AC to DC, right? This is
Yes.
yeah.
And a lot of customers using it for portable cars, portable equipment, because if the equipment need the AC, like a laptop or an LCD screen need AC power from a battery, they can use an inverter. Okay, that's usually how customers use the product.
That's great. So Brian, can you tell us a little bit about the different types of inverters? What are the different products available out there?
Okay. There are many different kind. Commonly, the two kind. One is the push sine wave we call, and then the second one is the modified sine wave. So, on the screen we have two, the top and the bottom. The top is the push sine wave. The bottom one is the modified sine wave. So the waveform in the middle show you how the output look like. The push sine wave look very like a sinusoidal. The modified sine wave it look like a square. Okay, square step square, and then also have dead periods as well. Okay, and so why they have two different kind? Modified sine wave is usually cost you less. Okay, cost you less to manufacture and design, and push sine wave is cost you more. But push sine wave you can use it in a lot of different applications. Basically, most of the application like power supply, printer, LCD, exercise, although can be used with the push sine wave. However, modified sine wave, they are a little bit picky. Okay, some application won't be able to use with modified sine wave like AC motor. Okay, if you connect an AC motor, it's not gonna turn. Your motor gonna acting very weird. Lighting, if you have a dimmer, like a triac dimmer, if you connect to a modified sine wave, it's not gonna work well.
I see,
okay.
I see.
And but some application, for example, like you burning some resistor for heating purpose, or power a power supply. Okay, it's gonna work because modified sine wave, the peak voltage is like 150 volt. It can power a AC to DC power supply. So depend on the design cost. Modified sine wave cost you less.
I see. And so the meanwhile AC to DC power supplies can be powered by the modified sine wave, right?
Yes, it can. Yeah, because it can operate at 140 minimum.
All right, you guys heard Brian. So if you guys have a modified sine wave inverter and you need to have an AC to DC power supply downstream, make sure to use a meanwhile AC to DC switching power supply. All right. So we talked about the pure sine wave versus modified sine wave. And recently, we have a lot of applications like solar inverters, energy storage. So the inverters, are they converting the AC power output, connecting to the AC grid? Do they connect to the utility line all the time, or?
Yeah, so there's another type of inverter called grid tie and non-grid tie. Both of them are push sine wave, okay, because it's grid, need tied to grid. And the top one I'm showing is the grid tie inverter, okay, meaning that the output can connect directly to the wall outlet or the panel. Okay, and there are many different kinds for different applications. Okay, so I saw on the slide, one of them is the BIC 2200 that uses for battery manufacturing. The second one is the EIG 5000, which customer use to cycling the power supply for burning, cycle the power back. And the third one is the you guys usually hear microinverter. Okay, those are connect to the grid to feed energy back to the grid. So the main purpose of the grid tie is basically to feeding the power back to the grid. So so that the extra power won't be wasted or you don't have to dissipate it, but go back to the grid to be like green. Okay, and there are different applications. So like I say, microinverter, people use it for PV, okay, photo voltage, and ERG 5000 use it for burn-in. And so those are able to connect directly to the grid. And the bottom one is the one that are non-grid tie, sine wave like the NTS, NTU series, the NTS 2250P series. Those are standalone. Okay, it cannot be used as a grid tie. Had to power a TV, a laptop separately.
I see. So when the customer is selecting a inverter for their application, they need to pay attention to whether or not the inverter can be grid tied, is suitable for grid tied application or not, right? The non-grid tie cannot be used on the AC grid.
Correct. Yeah.
Okay. Okay.
So they have to look into, I mean, what they are trying to do. Usually portable device is non-grid tie, and green feeding energy back to the grid need to be grid tie.
Okay, yeah. So that's how we're, supporting a lot of the sustainable applications with our latest releases, such as the BIC, the ERG. Those are some new product types that Meanwhile never released before, right?
Yeah, I mean those are green. I mean those are for green energy now. Because they are able to feed the energy back to the grid, basically to consume less power when you're doing the manufacturing process.
I see. Yeah, so now we've learned what kind of different inverters are out there. Recently, I think we launched a brand new inverter product, right? The NTN5K. Can you tell us a bit more about the special features of the NTN and how it operates?
Yeah, the NTN is we just introduced it like a few weeks ago. It had much more feature as compared to the NTS, NTU series. Okay, one of the I'm going to point out some important feature. The first one is the AC charger. So it has a built-in AC charger to charge the battery. Okay, and it's high power charger too. It's not like a few hundred watt. It's 4,500 watt.
Oh,
Okay,
wow.
to charge your battery bank. And then also it has the UPS function, meaning that as long as you have AC power, it will operate in a bypass mode, feeding power to the fridge, to the motor. Okay, and when power is out, the battery will pick up, and the charger will basically recharge the battery or maintain the battery charge.
And I think the you mentioned it's like 4.5 kilowatt charger, right? That's such a upgrade from our previous generation of product. Yeah.
Yeah, I mean, there's the purpose why we do it, and we can show you more in the next couple of slides when we go to the application. There's a reason why we did it that way.
Okay, are there any additional special features for the NTN?
Yeah. Second one is PV. Okay, it basically can take the charger MTV charger voltage and convert to AC. No, it's not basically not convert to AC. It had the function where if application has solar panel, it can take the solar energy, charge the battery instead of AC charge, so the energy won't waste. Okay, the solar energy can be used to charge the battery, and the battery, when it invert, it go to AC.
I see.
Okay.
I see.
And the third function of it is parallel. Okay, and three phase. Okay, it can parallel up to 6 units. Okay, for 30 kW output, that's a lot.
Yeah.
Okay.
Wow.
And another function is that it can be configured into a 3-phase Y config Y output. Okay, meaning that the customer can have 3 units all neutral connected, and they will have 380 or 400 volt AC line-to-line voltage. So this is going to be suitable for application that need 3-phase inverter.
I see. And I think for such high power inverter application, it makes sense to have the 3-phase output to power some of the more powerful industrial grade or construction equipment, for example, right? Okay, yeah. And I think I just want to point out, right? I noticed in the application diagram, we have the AC input and then also the AC output. So are they the same terminals or are they different?
They're different. I mean,
Mhm.
because a grid tie inverter, you have the same terminal because you can tie directly to the
Yeah.
grid. But for this inverter, it has an AC input and AC output. So so that you know, if the customer need to use in bypass mode, they have to connect an AC input to it.
I see. So just customer needs to be pay attention that the AC output is not grid tied and cannot be connected to the grid, right? Yeah.
Correct.
Okay.
And in terms of accessory, you know, it has it's console paired with the CMU2. Okay, the touch UI that we have to control and monitor the inverter over the internet. Okay,
Yeah, and I
that's
think
also.
we do have a special edition of the CMU2 that works specifically for power management, right? For the for the NTN series.
Yeah, it has a suffix E. Okay, the CMU2.
CMU2E.
Yeah.
Yeah. Okay, so we talked about, you know, this is a non-grid tied. Can you introduce us to a grid tied product?
Grid tie is the I showed the BIC. I saw the BIC 2200 instead of ERG 5000. So popular application, you know, to charge the battery and discharge the battery, basically it's bidirectional. It can out if you put AC in, it's gonna output DC to charge the battery, and then if the battery voltage is higher than the DC output, it's gonna invert. Okay, it's gonna invert the energy back to the grid, feedback to the grid. Instead of dumping it. So it's basically save manufacturing costs. And we're going to have a demo here. So we did a bidirectional tester, I mean a demo kit, okay? That show how much energy going back and forth,
I see,
okay,
I
between
see.
the grid and charging the battery.
Yeah, and then looking at the application diagram, so now the AC, there's only a single point of connection for the AC, right? Both the AC input and AC output is the same terminal because it is tied to the grid.
Yes, yes.
Yeah.
And one thing I need to point out is that the BIC 2200 cannot be used as a standalone inverter. Okay, it's a grid tie, meaning you have to connect to a grid in order for it to invert. Otherwise, it's wrong.
I think the R&D call this feature the anti-islanding protection.
Yeah.
Yeah.
I mean, that's what it's for. If there's a fault in the network that at the BIC still outputting the voltage, that will be a hazard. That's why it needs to have the AC voltage in order to output the AC power.
I see, I see. And you know, you guys know since I work with the PM team, I have a special sneak peek for you guys. All right. So since the BIC 2200 is a grid tied inverter, we have complaints from USA customer. Oh, they cannot use it on the, you know, the 115 volt AC or 120 volt AC. So the Power Solutions team and the Meanwhile team is working together to develop a U version. So the BIC-2200U that will be able to expand its input range to work at the low line input as well. So please stay tuned on news on that, and you guys should be able to order samples very soon. All right. Okay. Yeah, yeah. All right, so we talked about the different products and exciting products. Can you give us some application examples on how the inverters products are used in our daily life?
Okay. Here is another upgrade. Okay, the NTS 3200. Okay, so you saw in the photo, like I said earlier, portable equipment, portable workstation, portable card are the most popular application for the non-grid tie inverter. Okay, so on the slide is the light tower. Okay, the customer use the NTS 3200 with the battery, and then there is also a charger, MPP 360 to charge the battery. Okay, and there is also a solar charger built into the card, and to power basically a construction light. That means this card is used to you know, do on the road on the highway. You see it for worker to work at night, and then in the morning they recharge.
I see. So is there any reason why, you know, the NTS is 3200 watts output, right? Very powerful, but the charger, they selected a 360 watt charger in this application. So how does this impact the selection and influence for the customer?
I mean, it's because you only use it at night for 12 hours, let's say, and then in the morning you have 12 hours to recharge. So you don't really need to use a fast charger like a 1500 watt charger to charge your battery. That's fast. I mean, 360 watts is enough to charge for 10 hours, 8 hours. Your battery should be recharged and fully charged. This gonna, you know, I mean, lower higher power charger is gonna cost you more.
Yeah,
Okay.
yeah. And I think like for application like this, light power, they use it for construction sites, things like that. Maybe they only need it to turn on for a couple hours, but then they have the rest of the day to charge it, right?
Mhm.
So they don't need a super powerful charger. I see, I see. So can you tell us a bit more about like we talked about the NTN, the new product. Can you tell us a bit about the application example for that?
Yeah. One of the application is for EV roadside assistance. So EV is getting a lot paying a lot of attention now. So what if your EV dead on the road? So there will be a card that come by and then have to recharge your EV so that you can go to the charging station. So here is the that had 5 NTN 5K, okay, in parallel along with the CMU2, okay. So it also had a battery bank built into the enclosure. So you can think it's like a big portable battery bank, and its output 25 kilowatt to charge your car. Okay, in 5-10 minutes you can get like 10-15 miles to go to the station. And when the battery is dead, okay, go back to the station, is the NTN can also recharge the battery at 25 kilowatt at the same rate.
I see. And
Okay.
that is enabled by the high voltage model of the NTM5K, right? To have such high power density.
Yes, yeah. I mean, the 48 volt can also charge you at 25K as well. So that's why that's the purpose of why we designed this NTN with such a high charging current for this type of application. And I mean, if the customer doesn't need that much of high charging current or power, they can use the CMU2E or the SPPO1 programmer to lower the charging current as well. They don't have to use, so because higher charging current may damage your battery. Okay, some batteries smaller size may not be able to charge with such high current.
Yeah.
But the unit is designed so that you can control the charging rate if you want to.
I see. Because we recently, we talked with a, electric scooter customer. So if they don't need as much charging power, then we can use the programmers to lower the charging current. Yeah. Okay. Okay. That works perfectly. So now can you tell us a bit more about, the grid tied applications and how we're using them?
Yeah, grid tie, one of them is the ERG 5000 is used to, that's what we're using at the, when we manufacture a power supply in the production line. Each unit, each mean well power supply went through a burn-in of 30 or 45 minutes per burn-in time. And we all use the ERG 5000 to do the burn-in. So as shown in the diagram, the power supply is feeding the DC power into the ERG 5000, and the ERG 5000 is inverting the DC power back to the grid, and the grid in turn power the power supply. So basically, it's just cycling the DC power back to the grid, and overall, the power consumption is only like 20% total power.
I see. And these pictures are actual usage application of our factory, right?
Correct.
We're using them. I see. So besides power supplies, what are some other type of load or application customer can use this for?
Yeah, a lot. I mean, for example, we have customer asking, want to use it for e-fuels. Okay, they use the power supply. Okay, but they put the e-fuels in between the power supply and ERG 5000 so that they can pushing current to the e-fuel to make sure that the e-fuel is good. And another one is connector contactor. Okay, that need to do the testing and burn in during production. Customer also use the ERG 5000. I mean, instead of dumping the energy into the resistor bank, waste of energy, it gets go back to the grid. So a lot of component manufacturer, power supply manufacturer is assembling these units to save energy now.
I see. So this is very I think aligns with our goal of going green and building a sustainable future, right?
Yeah.
So in addition to these, I think we also have, the BIC. Can you give us some application examples for the BIC?
BIC, so so far we have like two popular one. The number one popular is for battery formation. Okay, is when you manufacture, when you do the battery, first time after battery complete, you need to charge it and discharge it. Okay, that is what is called formation testing, and that to make sure that your battery is good, that can be charged and can be discharged. Now, every time you charge the battery, you take power from the grid, you pay for the bill, And when you discharge it, you either discharge it with the resistor or you discharge with the BIC. The BIC is going to invert the power back to the grid. So the net, okay, you're going to be lost like maybe the 10%, which is the efficiency of the BIC.
I say traditionally they just use, you know, resistive load to burn them as heat. So now it's a lot more green, right?
Yeah.
Yeah. Okay.
And the second application is the photo on the right hand side, where where it's used to power a motor that can absorb the back EMF. So that when the motor has back EMF, it's the BIC would feed it back to the grid. Okay, instead of this application is not really green. For green, it's just like the customer doesn't have to purchase like a regeneration clamp to dump the back EMF back to the grid. I mean, back to dump into the resistor and waste it. It just go back to the grid, and so it just save cost. The customer doesn't have to design a regeneration clamp or purchase a device that take care of the back EMF.
Yeah, I remember the one of the engineering project was a customer was using one of our 1700 watt power supply, but it kept tripping the over voltage protection due to the back EMF, right? And then, you know, typically we would suggest the customer to add the blocking diode. They did that, but the back EMF ended up damaging their control board because it can no longer be absorbed by the power supply. Yeah. So yeah, in that case, I remember we recommended the BIC and it worked out great for them.
Yeah, I mean, it's a solution for the application, basically. I mean, if you put generation clamp on, you design your circuitry, it's going to have another EMI issue.
I see. All right. So is there another like more, you know, more related residential or, you know, more commercial application for us?
One of the this is the last one that the customer in Europe uses like a power wall in US here. So in the photo, so the customer have the solar panel and then a solar inverter, okay, that grid tie connect to the grid and also power the house, the home. And but when there's so much energy generated by the PV and nothing feeding back, it's the customer use the BIC 2200 to charge the battery. Okay,
I see.
dump all the energy there, reserve it. Okay, when it needed, okay, let's say that power outage, the battery gonna power the BIC and invert it back to the load, back to the house. So this is like another application for residential. Okay, it's become popular in Europe now. It's just similar to what Tesla does here with the battery pack.
Yeah, so if the customer does not have the energy storage, they just do the solar inverting, like they cannot store the power, right? They cannot store it and access it when they need it. And then when they need it most at night, they still need to get the power from the grid. Yeah.
And another smart way, this method also saves the cost when they have peak power. Okay, when because utility company usually charge you by how much you use when the peak hours, like at night, 7 p.m. or to 8 to 9 p.m. So those time, if you turn on the AC, you want to use the battery to turn it on, then it saves you cost.
Yeah, so this achieves what we call the peak shaving, right? Peak shaving for the energy saving. All right. So that's the last application, right, Brian?
Yes, so the last application, and the next one we're gonna do a demo.
All right, Let's jump into the demo kit. So we'll be back in 30 seconds, and we'll do some setup. All right.
Setup. Okay, so here is the
okay, so hope it doesn't cause a fire when we connect the batteries. Oh, should have caught that on camera.
Okay, so okay, you want to introduce
Yeah, we can. All right, so here is the so we're using the BIC bidirectional demo kit for the demo purpose. So basically this kit inside is a BIC 2200 unit, and then at the front is a CMU2E. All right, the energy recycling module, but it is specially customized for the demo kit purposes. So the interface may be slightly different from what the customer actually use it for. So we have a setting for the demo, the status to see what kind of state the BIC 2200 is operating in. And they also have a video option. Like when you guys take this to the customer, you can play the video to show them the feature of the BIC 2200. So this is all great, right? So so first of all, we're gonna go into the settings. during this stage, when you first power it on, you can set the max charging current, the cutoff discharging voltage, the maximum charging current, and max discharging current. So you would want to adjust these according to the power source or the battery's characteristics, so you don't overload or burn any batteries, right? So we've set it to 41 volt maximum because we're using three 12-volt batteries. That is like 36-volt batteries, okay? So basically we can put the BIC 2200 into the charging or discharging mode by setting its output voltage. If its output voltage is set to be higher than the battery voltage, then it will go into the charging. If it's lower, then it's the discharging. So we can go to status quickly to see. So the battery voltage right now is 38.3 volt, right? So if we go to the V out, we can set it to say 41, right? 41 is the maximum that we limit it to, and then we can just simply turn it on. And if we go back to the status, we can see that right now, the BIC is used to charge the battery at a rate of maximum 5 amp. Now it's tapering down because we set it to 5 amps. And it is slowly building up the charging the battery and then completing the charge cycle. And once the charging current drops to below 10% of the set charging current, it will complete the charge.
Yeah, and also you guys see this is how much power it takes to charge the battery. The AC power from the wall outlet is consuming, and it's getting lower because the battery getting full. So we see that the charging current get lower. That's why you see the AC power getting lower and lower. Okay, when this guy getting to like 0, it will automatic stop the charging.
Yeah, yeah. So yeah, you can show the customer, right? So now it kind of has the flow to showing that the power is flowing from the grid to the BIC and then the BIC to the battery. All right, so let's test it and then let's turn off the charger and then we can put it into the inverting mode. So the battery voltage is about 40, 30, 39 volt. So we can set the output of the BIC to be lower than that, so 38 volt. And then if we turn it back on, you will see that it is now in the discharging mode. So power is flowing from the battery to the BIC and the BIC back to the grid. So we're recycling about 62 watts of power right now. And that is because we set the discharging current to 3 amps. All right. Yeah. All right. So yeah, you guys see, and then once the battery, so we have the setting, everything's controlled by CAN bus. So once the battery voltage drops to below the setting point, the discharge cutoff limit, which we set it to be 38, you'll see that it will stop the discharging process so that we don't over discharge the battery and then damage the battery. So this is how this BIC is used in the actual application, and I hope you guys can find this demo kit very useful as well. So for the Meanwhile distributors and partners, you guys are able to order the demo kit with us, and then these are very well designed with a handle to carry to the customer and show them what our products are capable of. All right, so I think that concludes the demo. So we will turn back to the slides, and then yeah. All right, so I hope you guys learned a lot from about the inverters today, and so you guys should be more confident when introducing inverter products to your customers, right? I know you guys are experts in selling the AC to DC power supplies, but when it comes to the DC to AC inverters, it may be a little bit of a foreign territory. So yeah, that concludes our session today. And on the screen here, we show all the technical contacts of our engineering team. So if you guys have any questions about today's topics or about any Meanwhile products, please feel free to reach out to our experts here at Meanwhile USA. And before we end, I just want to quickly reveal, the next Tech Spark, which is happening 2 weeks from now on June 27th at 11 a.m. Pacific time. So the topic will be diving into the functionality of DIN rail products. So we'll be talking about the DIN rail all-in-one solutions, as well as how the other products and accessories can make the customers have a more complete automation solution. And this session will be hosted by our sales representative Tao, and then joining her will be our engineering Harland. Okay, hope you guys had a wonderful time. I'll see you guys next time.
Thank you. Bye-bye.
Thank you.